Hi, in this video we're going to look at solving second order differential equations. First of all, we're going to start with the first order differential equation. It says, show the solution of the differential equation a dy by dx plus by is equal to 0, where a and b are constants, is of the form y is equal to a e to the mx, where m is also a constant. Hence, find the condition for y is equal to a e to the mx to be a solution of the differential equation of a d squared y over dx squared plus b dy over dx plus cy is equal to 0. So, this is the first order differential equation, a dy by dx plus by is equal to 0. First order, we use the separation of variables method to solve it. So we're going to just take by over to the other side. So we get a dy by dx is equal to minus by. And then we're going to do 1 over y dy by dx is equal to minus b over a. Then we're going to integrate with both sides with respect to x. So we've got the integral of 1 over y dy by dx is equal to minus, it's okay to take the minus out of the integral sign, of b over a dx. Integrating both sides by dx, doing the same thing to both sides. That becomes the integral of 1 over y dy is equal to minus the integral of b over a dx. Integrating, the integral of 1 over y is ln of y, and the integral of minus b over a, well, it's just a constant, so it's going to become minus b over a times x plus a constant. Writing that out again, now we use a little bit of rules of logarithms. Log to the base a of b is equal to c, means that b will be equal to a to the c. So b is going to be y, and the base is e, and the power is going to be all of this, minus b over a x plus c. Right, then we're going to rewrite the plus c as e to the c by using this idea a to the m times a to the m is a to the m plus n, so we're using that backwards. And then we just say, because this is just a number, so we let e to the c be equal to a constant a, so y is equal to a e to the minus b over a x. This is of the form y is equal to a e to the mx, where in this case m is minus b over a. So if this is a solution of that first order differential equation, then possibly it could be a solution for the second order differential equation a d squared y over dx squared plus b dy by dx plus c plus cy is equal to 0. So if y is equal to a e to the mx, we're going to need to know dy by dx. So differentiating this, you bring down the m in front and write down the same thing again. So dy by dx is a m e to the mx. And then we need to know the second derivative, so differentiating that again, we're going to bring the m down in front, so we're going to get m squared, and then write down the same thing. So the second differential is a m squared e to the mx. Now what we're going to do is substitute these in here, this one in here, and then this one in here. So substituting into the differential equation, this one, the second order one, we get small a, capital A, m squared e to the mx, that's the second derivative, plus b a m e to the mx, plus c a e to the mx. Now we have a common factor here of a e to the mx, and we're just going to be left with a m squared plus b m plus c is equal to 0. So either this is equal to 0 or this is equal to 0, but a e to the mx is always positive, so therefore that can never be equal to 0. So therefore it implies that a m squared plus b m plus c is equal to 0. Now this is called the auxiliary equation. So the equation a m squared plus b m plus c is equal to 0 is called the auxiliary equation. If m is a root of the auxiliary equation, then y is equal to a e to the mx is the solution of a times the second derivative plus b times the first derivative plus c times y is equal to 0. There are 3 cases to consider, and we'll consider these in later videos, but this is what happens. So the 3 cases of depending on the roots of the auxiliary equation. So if b squared minus 4ac is greater than 0, then we know that gives 2 distinct roots, 2 different roots, and we can call those roots alpha and beta. Then the general solution will be y is equal to ae to the alpha x plus b times e to the beta x. We'll do some examples later in another video. If b squared minus 4ac is equal to 0, there's 2 equal roots, which is alpha. The general solution will be of this form: y is equal to a plus bx e to the alpha x. And then we've got b squared minus 4ac is less than 0, i.e. this is negative, we have complex roots, so the general solution takes a different format altogether. And again, we'll look at these in a later video. So we've got y is equal to a cos times some number times x plus b sine times some number times x. Now a and b in all these cases are arbitrary constants. Okay, so this is a summary of trying to solve a second order differential equation which is equal to 0, and looking at the auxiliary equation and the types of things that can happen. Okay, I hope you've understood this introduction, and I thank you very much for watching.